Welcome to today's Explainer, where we are absolutely going to transform the way you approach Cambridge mathematics. If you were sitting for syllabus codes like 0580, 4024, 4037, 4040, or specifically the 0606 additional mathematics paper, you already know that kinematics questions can feel like an absolute labyrinth. You're constantly trying to figure out where to go next. But what if I told you that applying differentiation and integration to kinematics problems, calculating the displacement, velocity, and acceleration of a particle moving in a straight line, isn't just a test of your calculus skills, it's actually a high-stakes game of chess against the examiner. Seriously, you need to think 5 moves ahead. Let me paint a picture for you by introducing 2 students you might actually recognize. First, there's Alex. Now, Alex knows the math, but Alex completely overloads the answer sheet with raw mathematics facts. We're talking differentiating and integrating everything in sight, just throwing numbers at the wall and hoping something sticks, but providing absolutely zero analysis or structure. And then there's Sam. Sam is always fighting the clock. Sam rushes the exam, completely missing the specific requirements of command words like show that or hence, and just skips crucial intermediate steps. Both of these students know their calculus, but both are bleeding marks. In this explainer, we are going to fix both of those approaches. We are going to teach you exactly how to anticipate the examiner's next mental move so you can secure every single mark available. Okay, let's dive into this challenge.
This right here is the ultimate frustration, isn't it? You know the calculus. You know the power rule backwards and forwards. You know exactly how to integrate a polynomial. Yet, when the paper comes back, you see these aggressive red pen marks slashing right through your multi-stage kinematics working. You literally look at it and ask yourself, why am I losing these easy marks? Well, it usually happens precisely because of the traps our friends Alex and Sam fell into. You might differentiate your displacement function perfectly to find velocity, but because you didn't explicitly state your initial assumption, or maybe because you completely ignored a crucial command word hidden in the prompt, your perfectly good math gets heavily penalized. It brings up that question we all completely dread. The truth is, the answer isn't a lack of mathematical ability, not at all. The answer lies entirely in the strategy of exam taking itself. It's about knowing how the game is played. And honestly, we don't just have to guess about this. We have the undeniable proof directly from the source. The principal examiner reports state incredibly clearly, answers are often too vague. Examiners want specific details. Think about that for a second. When Cambridge examiners sit down with their coffee to grade your 0606 kinematics questions, they're not just hunting for a correct final number at the bottom of the page. If they were, a calculator could grade the exam. No, they are looking for a complete, airtight logical argument. In mathematics, the word vague usually means what I call magical math. It means a number simply appears on the page without you explicitly stating the formula or the principle you used to get there. It's exactly what happens when Sam skips writing down v equals 0 and just jumps straight into factoring a complex quadratic equation. The examiner is sitting there thinking, wait, why are you factoring this? They want the specific detail. They need you to communicate exactly why you are doing what you are doing at every single stage of the problem. To make absolutely sure you never drop those easy marks again, we've put together a very clear roadmap for today's explainer. First, we'll uncover the kinematics trap. Second, we're going to reveal the method mark strategy. Third, we will expose specific examiner warnings. And finally, we will master critical analysis. Let's start by breaking down Section 1, the kinematics trap, and why we have to look way beyond the final answer.
The absolute biggest trap you can fall into is believing that mathematics is purely about the final numerical output. It's really not. If you look at the raw data from students like Alex, who just dump numbers onto the page, their papers are always riddled with red marks because they treat the exam like a basic calculator, rather than a canvas for logical proof. To completely escape this trap, we have to look beyond the final answer. What's really fascinating here is how Cambridge redefines what you are actually being tested on. The assessment objectives for Cambridge Math specifically prioritize logical, evidence-based reasoning and analytical depth over superficial breadth. They are deliberately targeting distinct cognitive domains: your knowledge and understanding, your application of that knowledge, and your deep analysis. This is exactly where we introduce the PEAL framework, completely adapted for mathematics. That stands for Point, Evidence, Explanation, Link. Think of it like this. Your point is the mathematical principle. For example, explicitly stating, to find velocity, I need to differentiate displacement. Your evidence is the actual calculus you perform on the paper. Your explanation is justifying the step you just took, like writing down, since the particle is instantaneously at rest, therefore velocity equals 0. And finally, your link is connecting that whole process back to the question's specific context, making sure you have the correct units. Understanding this framework completely changes how you structure your answers. You go from just doing math to actually proving your math. And hey, before we continue and dive into the exact method marks, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, let's move right into Section 2, the method mark strategy and the standardized sequence you need to use. This right here is the absolute core of our approach. Method marks are the points examiners generously award you for demonstrating the correct mathematical process, even if you make a really silly arithmetic error later on in the calculation. If you want to completely immunize yourself against careless mistakes ruining your grade, you need a standardized sequence. So here is our definitive blueprint, the 5 mandatory steps for securing every single method mark. Step 1, identify key elements. What is the command word? Is the examiner telling you to find, show that, or calculate? What are the exact initial conditions given in the prompt? Step 2, apply relevant principles. This is where you explicitly write down the formula before you even think about plugging in numbers. Step 3, execute your analysis with clear working. This is your peel, evidence, and explanation in action. Show the steps. Step 4, verify your results. Ask yourself, does a negative time value make sense in this physical context? No, it doesn't, so you must explicitly reject it on the paper. Step 5, present everything in the appropriate format. Imagine our student Alex rewriting a messy answer using this exact blueprint. Those aggressive red marks would instantly transform into beautiful green check marks, because suddenly the examiner can easily follow the logic from the initial displacement function all the way down to the final acceleration value, completely step by step. Now, this visual perfectly illustrates the core story you need to memorize to execute those 5 steps flawlessly. It maps out the exact relationships in kinematics. If your input is displacement, the operation of differentiation yields velocity. If you differentiate velocity, you get acceleration. And going backward, integration of acceleration yields velocity, and integration of velocity yields displacement. It's a perfect loop. Let's do a quick mental data scan challenge right now. Imagine you are given a velocity function, say v equals 3t squared minus 12, and the command word in the prompt is, find the acceleration at t equals 2. Your brain should instantly scan this flow. Okay, input is velocity, the output required is acceleration. Therefore, the operation must be differentiation. So you find the derivative, dv over dt, which equals 6t. Then at t equals 2, acceleration is 12 meters per second squared. Boom, done. But what if the command word was find displacement? Well, you look at the flow, you know integration is required, and you immediately remember you'll need to solve for c, the constant of integration, using your initial conditions. This flow is your ultimate cheat sheet. Keep it locked in your mind. And speaking of keeping things locked in, stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in our Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Having mastered the sequence, let's shift gears and look at Section 3, Examiner Warnings Revealed, where we learn how to anticipate our opponent. Remember, to win this chess match, you absolutely must anticipate your opponent's moves. Cambridge examiners have a very predictable pattern of deductions. They document exactly where thousands of candidates lose marks every single year. By studying these warnings closely, we can ensure our standardized sequence completely defends against every single one of their traps. Here are the top 3 specific mistakes, pulled straight from the principal examiner reports. First, answers are too vague. We just discussed this. It's failing to show those crucial intermediate calculus steps. Second, students constantly forget to check their format and presentation. This means carelessly leaving off units or maybe providing an exact fraction when the paper specifically asked for 3 significant figures. Third, answers are not specific to the given context. Let's do a quick find the flaw challenge together. Imagine a paragraph of student working that simply says, integrate acceleration 2t to get velocity t squared. Time is 3, so velocity is 9. Did you catch it? What is the fatal flaw there? The flaw is entirely about context and vagueness. The student completely forgot the constant of integration, c, because they didn't check the initial context of the particle's movement at time equals 0. The examiner commentary on a mistake exactly like that is brutal. It caps your potential marks immediately, no matter how good your integration was. So, building on that, the crucial point is understanding the massive difference between merely using terminology and actively defining it on your paper. Examiners explicitly warn that candidates consistently confuse key terminology. Let's do a quick speed-writing mental exercise. If the question mentions initial velocity, you must actively write t equals 0 on your paper immediately. If the prompt says the particle is instantaneously at rest, you must explicitly write v equals 0 before you even start solving your equation. If it says constant velocity,
you write a equals 0. Actively defining the terminology before throwing numbers into your differentiation or integration operations is exactly what the Peel framework demands. It provides the explanation and point before you ever get to the evidence. You are building a case. You are telling the examiner, I know exactly what these words mean mathematically, and here is how I am applying them.
All right, we are now entering the end game. Section 4, Master Critical Analysis, which is where we make the winning play.
Here is the reality. Anyone can memorize the power rule for calculus, but getting into that top grade boundary requires moving from merely descriptive mathematics, where you just describe the numbers on the page, to an evaluative level, where you are deeply analyzing the mathematical reality of the kinematics problem. Top-scoring candidates all share these specific traits. First, they identify limitations. For instance, when solving a complex quadratic equation for time after setting velocity to 0, they might get two answers, say t equals 3 and t equals -1. A standard student circles both. A top candidate evaluates the evidence, recognizes the physical limitation that time simply cannot be negative in the specific classical mechanics context, and explicitly crosses out t equals -1, writing reject, t is less than 0, right next to it. They justify their decisions with evidence. This also perfectly brings in our time management matrix. Top candidates allocate their precious exam time not just to frantically calculating like Sam, but to actively evaluating these assumptions. They don't rush. They spend the extra 10 to 15 seconds to evaluate the effect on the final conclusion, ensuring that their mathematics aligns perfectly with physical reality. And finally, we arrive at the ultimate defense against losing those easy marks: strict presentation conventions. Your exam paper needs proper headings, correct terminology, appropriate formats like utilizing exactly 3 significant figures when it's required, and incredibly clear annotations. You need to let the examiner clearly see your thought process. Structure your answers so beautifully and so logically that they literally have no choice but to award you full method marks. You know, students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but that only happens if they practice consistently with our weekly videos. So, here's your final reminder. Subscribe to our YouTube channel, Ace the Exams at @acetheexams_IGCS, to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by. Also, drop a comment below with your target grade for mathematics and tell us the biggest challenge you're currently facing. Our team responds to every single comment. Make sure to like and share this explainer with a study partner who needs it. Ace the Exams, your Cambridge success starts here. So, as we wrap up, I want to leave you with this final, truly provocative thought to mull over before you tackle your next past paper. Take a hard look at your previous workings. Are you just calculating the math, blindly hoping that the right number magically falls out at the bottom of the page? Or are you acting like a true chess grandmaster, thinking 5 moves ahead and strategically presenting an undeniable, logically watertight case to the examiner? If you can permanently shift your mindset from merely calculating to strategically proving and use the frameworks we discussed today, I guarantee you will absolutely dominate the Cambridge 0606 kinematics questions. Keep practicing, trust the system, and take total command of your exams.